Oh, it's quite good. It sounds quite still.
Yeah, we've got three to do
Okay.
as well.
Right, let's grab a quick picture of that. Sorry, everybody. Smile. Good, Sandy.
Yeah.
Cool. Richard? Thank you very much.
Sandy, can you just double check to see whether you can?
Yeah, so see that screen.
Beautiful. Okay. Right. So we are now at the end of 2025. I thought that it would be really good to do a roundup of everything in Azure that's happened this year. So there's a couple of things which are significant in Azure now. So it's changed over the years, but you have two conferences called Build, which occurs like around about anywhere between March and May, depending on when Microsoft get out of bed and decide that they want to do it. And then you have Ignite, which is in November. And does anybody know the history of these two conferences, first of all? Because it might be quite interesting for you guys to understand how Microsoft have evolved these. First of all, has everybody seen Build and Ignite? No? Show of hands. Ignite, no? Yeah, Ignite online on YouTube. Yeah. Yeah. So Build and Ignite. Okay. So Build was supposed to be the developers conference. You were supposed to build things. It was taken over from something called the PDC, or the Professional Developers Conference, which ended around about 2010. So every year and then every 2 years, Microsoft created this Professional Developers Conference. And when they started Build was very, very much focused on the developer community. And that was always around March to May. Then he had this other conference called TechEd. Does anybody remember TechEd? Most of you guys are too young, you see. So TechEd was the conference for IT pros. IT pro? Anybody definition of IT pro? Okay, so a developer is something that builds something. An IT pro is someone that fixes it or supports it. Okay, so somebody that deals with infrastructure. And all through the last decade, Microsoft created these two types of personality that they would support. So then Ignite came, and Ignite was like when you set something on fire and you put the fire out and you have the IT pros. But it actually morphed into basically a 6-month, replay the roadmap in the last 6 months for what's going on in Azure. So that's basically what it's become. But it was never intended to be that. It was intended to be two different conferences for different types of personas. So anyway, so I decided that it would be good to go through this year and maybe discuss some of the announcements, talk about and do this very, very interactively around where we see Microsoft going, and also what we think might be coming next year as well. So that's going to be a thought experiment for me. I feel like I've got 3 or 4 JetBrains licenses that I have to give away, because if I don't get people using them, then we'll be kicked off the user group program. So I'm going to take 3 or 4 answers from you guys about the highs and lows of this year from a personal perspective on Azure. So that's me, Richard Conway. I'm now the group CTO of Acora. I'll throw another license in for somebody that can tell me what it is and what it is that I do. Coffee fetcher? Nothing. Okay, nothing. Yeah, there you go. But I'm also the founder of Elastic Cloud, which was this crazy, zany hippie colony kind of company. And we ended up in Acora. So anyway, for my sins, and there's a lot of them, I'm what's called a Microsoft Regional Director. And so I get a bit of insight, well, quite a lot of insight into the Microsoft product roadmap. So I can tend to see in advance some of the silly things that they're thinking about, some of the things which they should be thinking about and aren't. And sometimes one of the things that you find, because you're in so early stage as a regional director, I've described the Microsoft product roadmap as a genetic algorithm, right? So what that means is that rather than consciously think about strategy, what they do is they, like big companies do, because they can't control a lot, they throw money at teams and go, see what you come back with. And so you'll generally find in Redmond that 3 teams will end up doing the same thing, and not always the best one will win. So in the products that you get and see. Okay. I'm also an AI MVP. Hey guys. Yeah, I'm also an AI MVP. I kind of resent that title a little bit. I've been an Azure MVP for well, since 2010, I think, and I love working with Azure. But more recently, pretty much all MVPs are becoming AI MVPs, which kind of weird thing. I don't know whether you guys have ever seen the Judge Dredd movie with Sylvester, right? Do you remember how every restaurant became a Taco Bell because Taco Bell won the franchise wars? Right, it's kind of like that. All the other MVPs are now becoming AI MVPs, and it will be very, very telling when you look at the news of what Microsoft's doing and where they're going. So, so we're going to talk about why 2025 matters for Azure. We're going to look at the big themes for this year, and we're going to look at the major feature launches by area, which are AI, data, Azure, and there's something special at the end. You may have missed this. I was lucky enough to be in Redmond in March, and we saw quite a good something special thing, and I think that it's going to pick up very, very quickly. So despite the something special being science fiction, it will soon be science fact, I think, within the next 5 years or so. And then what to watch for in 2026 is more of a dialogue that I want to have. So why 2025 matters. So I thought through a lot of the things that I've been seeing, and Microsoft is gaining a lot of ground. Do you guys feel this in terms of your day to day? So, you know, you can see that there are 3 mainstream cloud providers, and there's smaller, more niche cloud providers, which might be more secure for public government cloud, as well as private cloud. And you can see here that there's like a slight tip the scales from 2024 to 2025, and Azure's gaining a lot of ground. And one of the things that I found is that they're closing in on the enterprise space that AWS have had for quite a lot of time. And I just want to throw it out there because Google's the same, but Google have always been seen as the AI cloud. Okay, so I think that reputation, that credibility has part of it. And I also think here that AWS were a little bit slow off the mark with AI. You know, they produced Bedrock, but what do we think of Bedrock? Nah, okay. It's like it's not noteworthy enough compared to where Google seems to be going with Gemini and some of the developments that it's doing, and the fact that Microsoft is literally all over, like with partnerships, agreements, getting OpenAI in place, and all the rest of it. So I think that this has actually had quite an interesting impact on demand. And what I thought was quite interesting, because I speak to a lot of people, and I think that there's a vocal crowd on LinkedIn that always says the cloud is crap. We went there and now we're replatforming back on-prem, but or to a private cloud. But you know, the stats just don't show that. Okay, so what I'm seeing is that even though a lot of people are saying that, saying too expensive, we're moving everything back, I think those are still few and far between because I don't feel that we're seeing that. But I thought that this was quite interesting, and I validated this independently. There are there's a whole load of things that go along with that. There's jurisdictional issues in countries because in order to expand, you're building more data centers. You need to do it in sustainably friendly ways. What Microsoft call sustainability friendly, you can construe as not being sustainability friendly. Is there anyone from Microsoft here before I start my insults?
I'll give it on if that counts.
No, it doesn't. But you throw the best parties. Yeah. So sorry, you do that. You really do. But no, the reason that I'm saying that is because sometimes it's questionable. Like all the cloud providers are doing the right thing, especially Microsoft, but a lot of people complain that they actually take like renewable energy like out of the grid away from other paying customers because they're doing this at scale for multi-year contracts and stuff like that. So, oh, can I actually minimize that? One sec. Oh, how do I? Okay, that's. Damn it, no.
It's still recording and sharing. So.
Yeah.
Yeah.
Okay. I don't think I can minimize it all the time. Because yeah. Okay, so there's lots of different things there. There's a climate innovation fund. That's actually quite an interesting number. So Microsoft for one of their data centers is actually sponsoring a new fusion company. I can't remember the details. Have you guys heard this? Yeah, so they're basically by 2028, they're saying that one of their data centers could be partially powered by fusion energy, which would be miraculous, right? It would be incredible. So we'll see if that happens. But yeah, you can see that the sheer expansion just to keep these numbers is mental. Yes. I don't. I should do. I read that thoroughly. I put the reference there, but I think what happened was I started these slides like two months ago when I realized that I was going to do this talk, and then and then customer got in the way, and then I finished everything else last night. But yeah, I'll send these round and to go back to the original research. Okay. Right, sorry, that's back. I don't think I'll be able to avoid that if I move through the slides. Right, so big themes for 2025. What's really interesting is that I've discovered Google Nano Banana Pro, and it is brilliant at infographics, right? This shit is what GPT, like, what's it called? What's the image thing called? Not Sora. DALL-E, yes, DALL-E, the new DALL-E produced. When I fed it in a few things, which is like, but you can see that you'll really enjoy the Nano Banana Pro thing, right? It just makes such light work, especially when you haven't got time to actually lay out slides, and you just go, take all this crap, put it into a slide, and then I'll figure out how I'm going to explain this. All right, so where we're at is we've got AI everywhere, and it's literally everywhere. When we get to the Azure section of announcements, it's so small and puny, right? I felt so sorry for Azure. It's really got the short stick at the moment because absolutely everything that I went through in the book of news for Build and Ignite, these two annual conferences, is AI or associated with AI. So that tells us something about where Microsoft are positioning themselves and what they think their future is. So we're also looking at unified data and analytics. There are loads and loads of announcements over this. But I only actually found like a handful of real data announcements because it was data and AI announcements. They couldn't even decouple that. So data uniquely was a huge driver for 2015 to 2020 with Microsoft and other cloud providers. Machine learning was an adjunct to this, but now they cannot even mention data without mentioning AI. So I thought that was kind of interesting as well. Has anybody from security here? Okay. Do your security teams, do they get all wet and dreamy over zero trust?
Yeah.
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 I definitely know yours too.
Yeah.
So basically zero trust is this idea that that you build a cloud platform where developers can't do anything. But nobody's experienced that. Yeah. Okay. Anyway, so there's more innovations in that area where you'll find AI is at the center of it to work out what you actually want to do and enable things dynamically. And then edge, hybrid, sustainability. There's lots of things on the infrastructure side which I didn't map to do with being able to set up like much faster networks between the cloud and on-prem. So like so gigabit networks. But yeah, I didn't want to dominate this talk with that. But there were a few things there. So if we just focus on AI, I wanted to just bring a focus on where things were in the UK at the moment. So how does the government see things? What do we see things in terms of investment? And what do we see like simple things like this, like company registrations, like the number of direct company registrations that went up between 2023 and 24. I mean, look at that spike. Like absolutely incredible. Everybody's building like AI companies, direct companies where you can tag on company's house.
Do you make that bigger?
Do you know what? I don't. Yeah, here we go. There we go.
The one on the first, yeah. What do you mean by dedicated and diverse?
Where is
On
that?
the left-hand side, the chart. Of that.
Oh, God, I have no idea. I just looked at the overall trend. I think diversified in this case means that it's not exclusively like tagged with AI. So it might be a company like ours which pretends and calls ourselves AI. But oh God, another thing to edit. I keep doing this, right? I fuck up all along and done it again. And I have to edit and bleep things out of the YouTube. Sandy's was the worst last time. Yeah, no, you weren't. Yeah, I thought you were at the time because I like filter all this stuff out, but unfortunately the tech didn't. So
Team Dedicated is a company that just does
AI.
and then Diversified is either a company that was pre-registered that's now doing AI, but its company registrations probably.
Yeah, that's right. So you can have many tags. I thought that as well. Yeah, probably much fewer. And I think more to the point that if you look over here at the investment graph, like these new companies are just following the money, right? If the money dries up, they'll stop. And maybe I think what you're seeing here is a little bit of latency year on year.
I was just going to say there's a correlation between investments. I think 2022, 23,
Yeah,
quite a high amount of money available.
Yeah.
And so the number of startups that were built and started just went up.
yeah. And you know, the other thing that this could be is this could also be a consolidation drop, you know, because when companies are bought, sometimes they're folded into other companies. It may be that over those years there was a mental amount of financial mergers and acquisitions that just basically bought any old crap. And, and well, I mean, one of the reports that I read and I've commented on talks about out of interviewing 200 companies, 158 of them were considered ChatGPT clones. So I think in terms of measurable value, we're not quite there yet. We're seeing a lot of the same type of company emerging in AI. But anyway, I'll leave you with these slides too. And I've just realized they're in the wrong order, which I typically do. This is Google Nano Banana Pro. I love Google because their names are even stupider than ours for projects. But I put the slide in the wrong order, but let me explain this. Microsoft have created a new inference SDK, and these things. So AutoGen started out life as an agentic platform. You could create these agent workflows, and I remember like even as far back as God, it must have been like 18 months, 2 years ago. Somebody did a talk at this user group and built Snake in AutoGen, and they created a development team. So the developers, the games designers, the testers, all the rest of it, until they got to the end of this and had a game. And we went through why that was a good thing at the time. Then you've got semantic kernel, and semantic kernel is a way of abstracting like all of the hard stuff that you need to do to build like chat applications and to be able to understand the context of what people are asking when they're asking questions and things like that, to understand how to abstract the idea of vector stores and all of these things and kernel memory. And what Microsoft have done is that these were discrete, and it's basically because they were built by two different teams. And so it's taken some time, but this year they put them together into this new AI inference SDK. So if some of you guys were working with this, you would have been impacted because the namespaces would have changed, how you relate to these libraries, and the fact that you need to upgrade them as well. And the foundation for this is AI Foundry, and we'll look at some of the things that have been developed with Foundry this year, and of course the base sets of services that Azure has around vision and speech and things like that, and a whole base sets of models for anomaly detection and others. Okay, this slide I meant to put before. This was something that I got exposed to actually when we went to New Scientist Live, and this is from a report that somebody referenced called the Meta Report. And I've been quite vocal on this online, and everybody thinks that I'm just like a miserable has-been developer and that the future of engineering is vibe coding. But it's only the business people that are really saying that, and it's because what they want to do is like sack all the software engineers, employ a set of children through some kind of slave labor policy, get everybody to vibe code, and and then and basically distribute a bunch of crap software. So I thought this was quite interesting, this report, because what it actually, I'll summarize this, because there's some methodology here, but on average, developers who are quite accomplished took 19% longer to complete issues, GitHub issues, using AI. So they were using a bunch of different tools: GitHub Copilot, Codex, and a few others. What's the other one? Cursor as well. Cursor Pro, Claude. And this was done over about 1 million lines of code, I think. Interestingly, all these developers thought they were being 20% faster than they actually were. They were 20% slower almost. And organizations who didn't measure this until then, and you can see from the box plots, organizations thought they were 40% quicker. And, so everybody's perception of the use of AI was way, way, way more effective than it actually was. It was actually more of a time suck.
Was it?
Yeah, that's so. I mean, I would say from my own experience, because this is quite a full report, but it is pretty much because a lot of these developers, like me, when they use AI, they go down rabbit holes very, very quickly. And so I think that that AI hasn't contextualized what they've wanted to do.
Be that guy, but is the task complexity measured in the standard deviations there? Or is it not?
I don't know. I'm sure there's definitely some statistical methodology that they talk about in the report. I've got a link to the report, but it's really famous. If you just type in Meta report, METR, there's about 4 of these that are quite samey, but this is the one that everybody references. But I thought this was quite interesting, and this is not a play on code gen specifically, because we've had a lot of success with code gen tools. I think this is a play on navigating your business around solely using AI to solve problems. Yeah.
See that you copied and pasted code with the error messages and expected it sorted out.
Yeah.
And if they've actually looked at the responses and the functionality of the response, they might see that there's like certain things that are clearly wrong.
Yeah.
Because they've copied and pasted it without really looking at what it's doing. You end up spending a lot of time going backwards and forwards, copying and pasting, and like expecting it to fix it automatically, and that's not going to happen.
Yeah, I think that's the thing. It's like everybody wants to save the time, but doesn't contextualize and doesn't really understand the services or SDKs that they're using properly. So they can't. It's supposed to shrink your time when you know what you're doing, not when you don't know what you're doing. And I think that there's been in exactly the same way as we've kind of laughed at all of the lawyers who, like 600 of them, who've gone to court and used AI to hallucinate their cases. There's a lot of people who don't have the rigor and the experience in software engineering who jumped into AI, who have now shipped products, and they're liable for them because they've got security issues and all kinds of stuff. And they can't contextualize it because they've never gone through software development lifecycle before. So I think this reports like this are really good to just take us back to basics, which is that we need to have strong software engineering disciplines when we're writing code, and this is an aid to writing code, not a solution to write the code for us. Okay, so some of the things that emerged this year, we had model context protocol, and I'm talking about these things from a Microsoft perspective. So MCP, everybody's talking about, everybody has MCP servers now. They've gone like wildfire in exactly the same way as when people started wanting their own REST APIs and moving away from SOAP. It was almost instant, so now all the vendors have MCP servers, and the expectation is that you can talk to them and get AI responses and all the rest of it. So Microsoft have thrown themselves into this. They didn't originate it. It came from Anthropic. but they're certainly working on like next generations of open source, and this seems to be quite a friendly community that's progressing really quickly. So I did a talk. It's going back a year now, isn't it? Maybe. Or was it the beginning of this year? Beginning of this year. Yeah. And like Azure AI speech took a really big spike. And it used newer models to be able to synthesize voices so that you could use a much smaller sample set, like 30 samples, and you could codify it in this horrible looking XML language, but at least it was something. So that you could actually take describe voice files, the metadata, so angry, sad voices, happy voices, laughy, that kind of thing. And also accents and also languages and stuff, and you could bundle it all into to a metadata file, and then you could have the voice model as well. But the synthesis from 30 small samples was fantastic. Prior to this, you had to have 1,800 samples, which if you want to get perfect voices and you want to get like intonation and accents and things like that, you still have to go further than 30 samples. But AI really, really accelerated that. So that was a release earlier this year. Then you had this idea of multimodal interfaces. So this was all the rage again at the beginning of this year, where you could send lots of different things to AI. And I remember we did something really interesting with multimodal when it was first released around object recognition. Do you remember? And really, really powerful stuff because it became available to everybody. And the way that you would have to do this before is through more complex machine learning data sets. Like Microsoft's one was called RES, I think, where they use transfer learning to train loads of objects, mountains and sheep and all the rest of it. And you've detected a sheep, it's upside down. Now you can do this with an AI model because of the release of this multimodal stuff. AI language, you named entity types, GPT image previews, better text analysis, research agents. So all this multi-step reasoning was released, like agent ops, so workflows around agents, things like red teaming as well, which we got into. And this idea of going from a very, very passive chat, question and answer, to doing things, and single responsibility. GPT-4o was released with audio, which was great, and also streaming audio. I remember the year before we built something and streaming audio wasn't available, so we had to do batch audio when you click a button and it would just send WebM files up. We would decode them, we would transcode them into AVIs and MP3s, and then we would use a model to process that. But then you ended up with this incredible streaming capability where if you wanted to, you could stream directly from the browser into these models. Then, Azure AI Foundry had a model catalog and third-party models like Grok. And so, Microsoft have ended up with an ecosystem of vendors as well. So not just the core focus, which was OpenAI. Right.
Is Azure or Microsoft truly innovating in this space, or they just playing catch up with what everyone else is doing?
It's a really good question. So I don't actually think that Microsoft innovates much. I don't mean that in a way to detract. I think that what happens is they do a lot of research and it takes them longer to sync that research into the core business. And so where they play catch up, they go, oh hell, we need to buy a company. And I've seen this all through the points of Azure. Well, GitHub. So, but they have a lot of good internal projects, but they cannot monetize them and commoditize them fast enough. So they tend to accelerate with acquisitions and partnerships. So this is what we're seeing. This is why they just threw a whole load of money at Anthropic recently as well, because they know that they have to own this space. And so I think it's sad, because if you look at what goes on internally in Microsoft, there's some fantastic research. You know, they have billions in budgets with Microsoft Research, and you know, across a lot of their teams in Redmond that are allowed to just play and come up with things. Also, a lot of cloud solution architects are pushing out a lot of good reusable code on GitHub, but a lot of it never sees the light of day to be productized, because Microsoft's just too big. They can't do it fast enough. So you'll find that they tend to innovate through acquisition now more than internal development.
So what is the edge over AWS?
Well, AWS can't deploy OpenAI. Google won't let them deploy Gemini, I don't think. So, yeah, but everybody's got Anthropic and everybody's got Llama. We're talking about unique differentiators.
Yeah.
So
it's still the API.
yeah, but they can. But the thing is, so at the moment they can control. You know, by pushing out loads of money in infrastructure, they can control the pace better of OpenAI in the same way that Google can with Gemini. So I think this is actually why AWS has waned a little bit, because they're not really seen as the AI cloud in the same way as Microsoft is through their partnership, and Google has always been. I think the other thing that Microsoft are doing really well is they tend to work really well with the platform. So taking everything away from developers. AWS have generally tended to be the infrastructure cloud. So a lot of developers who are hardcore developers bring AWS into their organizations. They spend a lot of time building good software frameworks, but it's very, very nuts and bolts. And even though there are a lot of good services in AWS, I don't think they're on par with Microsoft in the way that, you know, being able to sync security with Entra, being able to sync monitoring and observability, and putting all of these things together so that they're as seamless, and developers have to do less. And it's true.
Yeah,
It's
that's
true.
the advantage.
That is the advantage. Entra is at the heart of everything. AD was at the heart of everything on-prem. And, you know, people have already got these directories set up, you know. So
Do you need to innovate from perspective in this race?
No, but AWS had a big advantage, right, for enterprise customers. There's so many like enterprise big banks, whatever, they're all on AWS. So they're kind of, even if they want to not use AWS for AI, they're kind of handcuffed or tied to that. So I mean, Microsoft has come up because of Azure
Yeah.
and AI, I think. That's worked to its advantage, but
Yeah.
AWS already had that advantage.
yeah, so I think where I've seen large enterprises that they'd rather pay for two clouds rather than one. So yeah, and I think that they're happy to deal with all the problems. Plus you have different factions and different departments in big banks and other companies that like different clouds and will always use them and find exceptions for them. I think from an AI perspective, I saw a lot of companies where Microsoft aren't clearly the leader anymore, but in this space, they're still ahead, but you know, the gap has closed. But what I saw a year ago was that they were quite far ahead, and a lot of people were going, right, let's set up like an OpenAI GPT-4 service. You know, we want this platform enabled, even if they had data in AWS. So they'd then be setting up a polycloud infrastructure just to use and test this.
I don't see that translation on the other cloud vendors. So I think that's quite important when
Google has the same, has similar to Azure Foundry, has agent toolkits and stuff.
does it have Copilot?
It doesn't have Copilot, no.
They all build single
You don't need
agent
to use
platform.
Copilot, right? You can use Cursor.
But no, it's what, yeah, that's what I'm saying. It's like in terms of
Yeah,
you've got business people who don't know how to code.
yeah,
And they're trying to come into the AI space to understand the return on investment.
yeah,
In terms of that translation, it speaks to a broad spectrum of people from different skill levels.
yeah.
Really has
And-
the advantage.
And I think that's the thing. I think that it's a really good point. A lot of this is the intersection between code and no code or low code. So putting well, effectively application development into the hands of people, just like with Power Platform, this has now become the new Power Platform. So everybody was building all these crappy Canvas apps that nobody uses all over the place, just like with, yeah. And now they're doing the same with Copilots. But this is key, right? This is absolutely key. You have an explosion of stuff, whether it's citizen development that are building Power Platform because they don't have the ability, they don't have the software engineering background, but they have the SME access to SME knowledge about the problems they're trying to solve. Then you have excuse me. Then you have people that build their own reports from Power BI. So they'll take Excel spreadsheets and offline data sources, and they'll be using that themselves. And now you're getting a similar generation of citizen developers who are building their own co-pilots to do the same thing. And some of it will go mainstream and become part of an organizational piece of software, but a lot of it won't. Okay. God, I'm on slide 10 of 30. I don't know how I ended up with 30 slides. I literally cut and paste bits of the Book of News, to be honest. Okay, so this is something that was announced at Ignite, which is Agent 365. It's Microsoft's reflection on the fact that the governance surrounding all of these agent frameworks and access to AI is very, very difficult. Like, so the first thing that I find when I'm talking to our customers is that they're scared because they don't know who's building agentic frameworks, who's using ChatGPT, who's using any AI products. And so this is an attempt to build a live registry of who's using what, whether it's the co-pilots, whether or not it's AI Foundry, or whether it's third party, if the control mechanism is a single sign-on gateway through Entra. Okay, so you can see you've got the ability to do data governance down here, or maybe you can't with Microsoft Purview. You've got the interaction with Entra. So if you're building agents, then you know, who are they? What can they do? You've got threat protection. So, you know, the extension of things like prompt injection and all of the things that are going on in the background where agents and people are using prompts to try to understand and contextualize what it is that they're asking or trying to do. And then you've got this productivity workhorse here, which is all of the link to the apps like Copilot. So these are basically the four pillars of this new Agent 365 framework. And I took a screenshot from Ignite of what this looks like, but you can see the idea here is that you basically track individual agents because they're actively all part of a registry. Everything uses goes through the single sign-on gateways through enterprise apps, whether or not they're non-interactive users as well. So agents have an identity in exactly the same way as services and anything else in Azure has as well, and it gets recognized through here. There's some things within Microsoft Purview as an extension to this called security posture management, and there's some great dashboards that you can get out of Purview now that will show you your risk. So they'll look at things like, you know, understanding the prompts you're sending, understanding the type of data that agents are using. So some types of data are recognized through DLP labels as well. So they'll have tags on them, confidential, highly confidential, all of this. And then Purview will work out whether or not you've got a risk from any of the AI activity that's going on in the data that people are using. It is, yeah. So very much so. It's like, it's literally Microsoft's data governance strategy. And just recently, it's had this new AI input. Foundry. Foundry is literally now at the heart of everything. And God, I love this nano banana crap, right? It's just like, it's brilliant, isn't it? It's just like you just throw it a bunch of words and go, I want it to look like this, and I want it to look a bit of sassy, and a model router, I want, you know, and it just goes away and builds you some stuff.
Is this AI generated?
Yeah, this is Google generated. So yeah. Yeah, so I think so this is the Google image generation is the best that I've seen today. My son put me on this the other day. He was like making silly things that look quite fun, and then
Did it label it also?
yeah, it did everything. It did absolutely everything. You have to be quite clear with it, so you've got to give it some very specific instructions, but you can tell it how you want it, where the arrows go, and all the rest of it, and the links. So yeah, so this is more of the same around multi-agent workflows and hosted agents, like discovery, so MCP catalogs and things like this of tooling, and the agent framework, which is an open source SDK. I'm going to whiz through these slides a little bit quicker because there are so many of them, and we can go back and we can talk about some of these things in more detail. Data. So SQL Server. Interestingly, so a lot of new things that are supported in SQL 2025. So I was always against anything that's semi-structured and should be stored in a data lake. So I never really took seriously JSON support in SQL, but it's so convenient and it's got much faster. Because I think that I've very much grown up with as part of the Hadoop generation and Spark generation, where I've looked at JSON as another file type, and that sits and resides in the lake. And I think for so many years I looked at how XML was used in SQL, and you'd use XPath and other things to navigate it, and it's very, very slow in SQL. So it's very slow in most developer technologies, which is why people moved away from it. And I saw a lot of SQL developers doing the same for JSON, like trying to navigate like big, large, complex JSON structures. They're not very good, in terms of their memory usage as well. And so I prefer looking at these things at scale rather than row-wise, so more column-wise. Okay, so we've got JSON support, REST APIs, and change data capture streaming. We've got replication to Microsoft's OneLake with database mirroring, which is quite nice. Lots and lots of little performance things, especially around locking optimizations and things like that. We've got, yeah, I put a hung by Microsoft Arc. I haven't really been a user of Microsoft Arc. I've seen I've seen so many different incarnations of on-prem versions of Azure, and none of them are really stuck. I thought it was really cool right at the start of the cloud back in 2010. I can't remember. There's been so many different incarnations of this, but now I just think just stick it in the cloud. You know, it's secure enough, it's scalable enough. You know, and just put all the SLA on Microsoft. Why would you want to bring this into your office, into your data center? So can't say I'm a big fan. Like one of my devs showed me SMSS 2022, which I hadn't looked at. I was very old school with SQL Server Management Studio, and it was always something that you just got used to if you're a SQL dev. But yeah, the latest version actually is quite nice. I was pretty surprised. Microsoft had done some good updates on it. Yeah, I put a yuck by this new Python driver for SQL Server. I did actually try it. It's still a bit like, yeah. There's a lot of things that you need to get right on the driver side for it to work in terms of versioning and other bits and pieces. So I don't think it's quite stable enough yet. Horizon DB. Oh yeah, go for it.
Just a quick question. When we go back to the so when you say it provides a way to access AI models of choice, does that mean the system is open to non-Microsoft AI models?
It is. So I mean, I've used AI models within my stored procedures, and you just need to give it an endpoint, and you can manage the credentials through master keys. So, you know, if you set up even an endpoint on AWS, as long as you have the routing capability there, it makes it very, very, very easy to use LLMs. So not a huge user of Postgres. I've only used it a couple of times in my career. People that tend to use it and are quite close to the open source community tend to use it, I think, more for their geolocation type. That's right, isn't it? Applications.
Yeah, so I mean, PostGIS is.
PostGIS, yeah.
Biggest. I mean, there are people who use it pretty much anything, but it's basically the best geospatial.
Yep. So I think now there was the ability to do a managed instance, but now it's turned into like a first party service, Horizon DB. So you know, scales up to 128 terabytes, lots of replicas, huge number of vCores that you can add. So it just makes it easier to with the managed instances, I wouldn't natively have gone, I'm going to deploy a Postgres because I think it was still a little bit too infrastructure-y for me. But I think this is now the same thing, but it's a translation onto the platform. So it's the kind of thing where I would just click a button and just use Postgres endpoints rather than have to worry about managing Postgres. So that's also a bit of a first. Right. So I felt I needed a table in this, so I asked ChatGPT to do a table. So it might be utter crap, but there's a new Azure document DB which is based on the open source Mongo compatible, and yeah, I think this is. I couldn't be bothered to change this. I did it like late last night, and it. I think this is an example of ChatGPT completely misinterpreting some of the info that I gave it, because the background of this is open source, so it just assumed that it picked up one of the pieces of content and said, you can deploy this on any cloud. And so it didn't treat this as a platform service, which is what it is. But anyway, yeah, it's a new service. I felt I had to say it because I'm literally just scrabbling around looking for non-AI things. Okay, I want to show you the next infographic because it's really, really sassy. Yeah, it picked that out on its own from Fabric, and I thought that's not what I asked for, but I kind of thought, do you know, I've got to keep this. What do you guys think? It's a bit weird, isn't it? But it's kind of funky. Yeah. You should all use Google Banana and Nano Pro, but we should all think of a collective better name for it, and maybe just petition Google because I can't keep the 4 words. It's like a little bit too much. Anyway, so this is so there's this new Fabric IQ, and I thought this was quite interesting because does anyone remember Microsoft's digital twin? No? Yeah. So you guys would. So the digital twin was supposed to model what we see in the real world in the digital model, so that you could build an ontology of an office building. So you have chairs, you have floors in an office building, you have tables, workstations, printers, all of these things, and you could build this ontological hierarchy to say this is what offices look like, and then you could construct a digital twin on top of it. And a digital twin is just a graph, right? At its heart, it's just a graph model. So Microsoft scrapped digital twin, and what they've done is they've reintroduced digital twin into Fabric now. So they didn't talk about it for like 2 to 3 years. It's one of these things where they just go, we're not talking about this anymore. And if you're using it, you should probably think twice about it. But now it's being reintroduced, which probably means that there's a push from customers again around IoT, which might have been a little bit dead. People thought it was too expensive, so the services weren't consumed. So Fabric IQ is quite interesting. We still don't know quite what this is, but if you can read between the lines, what it basically does is it uses AI to build that ontology over the data that you've mapped into Fabric. So you can see here, you've got things like customer relationships, your entity types for assets. Then you've got your how you bind your data definitions, your dictionary on top of that. And then there's a native graph engine, which is present in Fabric. You can see this now, and even GraphQL endpoints, which are exposed. What Fabric IQ will do is it will put the two things together to contextualize like your scenario. So whether it's a supply chain or something like that, and it will effectively build that ontology to allow you to refine these graphs. So you can see it. It's where AI aids the semantic understanding of how to describe what you're seeing and all the relationships between them. Okay. So we've got one thing which I wanted to just show you because I think this is quite cool. It was released earlier this year, called Translytical Workflows, and the translytical is a combination of transaction and analytical. So it's quite a cool thing. It annoys me that this was overlooked. It wasn't actually overlooked by a lot of our customers. They're like, when is this going to be available and out of preview? And it's because this is actually a common business problem in that you have a lot of crap data in your operational databases, and you go through a cleansing process within your analytical platforms. And it's not actually beyond the pale to do things like this here, where you can take the cleansed analytical data and push this all the way back to your operating model, so that you've got much cleaner data. And there's some capability in Fabric user data functions to do that. The ability to modify source records and things, and also you can see that you can create workflows like this, so that you can send Teams messages and emails to get somebody to approve those changes. Wasn't really picked up, but I think this is quite a nice feature where you can go all the way from the end. Basically, Power BI all the way back to your source system if you're taking from a SQL platform, like an operating platform. Okay, right. This is where this makes me a little bit sad, actually, because there was not very much about Azure in this book of news. For the last 12 months, like everything was AI. You know, there's a whole bunch of stuff that I haven't added here, which is more Copilot centric. But I wanted to pick one thing out. Have any of you guys done web development with, like, in old school times with IIS, you know, and .NET code or even ASP? Yeah, okay, and COM, okay. So Microsoft has finally released an app service managed instance, which can allow you to write applications like that so that you're not just dealing with service endpoints through functions or web apps or static web apps, and that you've got more control over the operating system. And there have been points with a customer where they actually built a Windows service this year, and I had to decouple this and put it onto because I needed it as a proxy service to do something within the domain. So I had to have two things instead of one. So, you know, even for my use case, this would have been fantastic, but there are still a lot of legacy use cases which need underlying access to the operating system from older web applications. So I shouldn't be excited about this. I think it's my age, but I thought this was quite cool. And it's pretty much the only thing that I could find that was a totally AI-free announcement in the book of news. Okay, so Entra, again, there was loads of Entra announcements, but they're all around agentic AI and what they call fleet management. So understanding all of the agents and their fleets and their life cycles, and understanding what this means from an identity perspective. Yeah. Okay, I'm on slide 21 of 30, and I really need to hurry up. I want to get to the fun stuff. So yeah, Entra embedded into absolutely everything, even the agentic workflows and all of your identity points as well. So we talked about I think it's data security posture management. So this allows you to do the risks assessments, assign data to DLP or sensitivity labels if you've done that work. And you can do things like block agents. If you've got these policies in place, you can stop agents from sending things like national insurance numbers and other things. So all these foundation stones that people have built in M365, you can now apply to this new world of AI. The idea is that Purview actually helps surface, inherit them, and tell you when somebody's trying to violate some of these policies. Agents are. You've got some risk management for AI, detecting the risky behaviors that we talked about, and the ability to go in and investigate. Purview's been good at that. You know, it's got its own investigation workflow for things like data quality. So you can run a data quality engine. If you see a bunch of crap in your data sources, you can actually assign that to somebody and say, have you fixed that? You know, there are still too many nulls, or this is out of bounds, or it's untyped, somebody would need to go in and fix that. Otherwise, they get spammed with loads of Teams messages or emails.
Can you guardrails?
So that's a really good question. Yes, you can. So there's an application called I think it's Defender for Cloud, and you have to have that installed. Then what that does is it will allow you to push this out to servers and desktops, and then it will stop you from doing certain things. So, for example, you know, if I'm not supposed to, by policy, to use certain types of data or files to upload to ChatGPT, because those will be tagged with DLP labels, it will just tell me at source, no, you can't do that. There's other means to do this. I think there's oh God, I've forgotten all. There's like other applications that are that are proxy type applications like this that do these sorts of things on desktops, but this is Microsoft's version of it. Okay, so a couple of other things that I thought were quite interesting. I started doing this 3-4 years ago. Gosh, you were the expert on this, which was the Microsoft Planetary Computer. So this was forgotten as well, but it got an upgrade this year, and I mentioned, and it's basically got a whole load of Earth observation data, so satellite imagery and stuff like that. It's got a bunch of pre-configured Jupyter notebooks to allow you to do like a whole bunch of stuff on this data for biodiversity models and what have you, but also because it's based on scaling virtual machines, and especially on a Python framework called Dask, it allows you to scale all these activities horizontally in a very HPC style way. It's accessed through an SDK and a bunch of APIs, but the idea is that there's just a catalog of all of these planet-wide data sets in there. I think we were using it at a point, weren't we? Sustainability. Yeah. So this is now GA. I thought I'd mention this because I was literally looking for something that wasn't AI, and this isn't it. Yay. Then I found something else as well. Have you guys come across this? This was announced back in March, called Microsoft Discovery, and it basically allows, it's a set of public databases that allow you to create like R&D orchestrations for stuff. I didn't read too much into this. Like I said, I'm not really. Yeah. So basically, this is one of Microsoft's biggest customer bases is actually people that do R&D, whether it's drug discovery, whether it's looking at the skies and stuff, because the volume of data that they store and the amount of compute that they use is just immense. And so in order to facilitate a lot of this R&D, they've got like a whole load of data sets that are available publicly, but there's also the ability to create your own in a certain way, and then use all of the tools that we've talked about to build like agentic workflows on top of it, but from this R&D context. So yeah, I haven't actually tried this. Myself, but it's something that I want to look into. It's for researchers. It's like it is, yeah, it's a service. Yeah, it's called Microsoft Discovery, but it's for people that do R&D. Yeah, to allow.
Paid service.
Yeah, it's a paid service. Yeah, so I think this is actually in use by Microsoft Research themselves. So they've just surfaced this up for the traditional Microsoft customers. Right, we're nearly there to the fun part. So something special. How long have we got to pizza? Minutes. Okay, so right. So this is what I'm talking about. Look at all this. It's brilliant, isn't it? I know. So this slide is for you. This is effectively a GitHub excuse me, GitHub slide. So a lot of the practices that we talk about. Okay.
Can I replace that use with Pete?
Can you what?
Replace that use with Pete?
Yeah, I would love you to. Yeah, would you like to replace your CISO with this as well? Huh? Okay. I thought I was going to start something. Yeah. Anyway, so basically the developer is at the center of this with the wizard hat, and all of the things that you can see here are now AI driven things, predominantly from the perspective of the GitHub models, which sit on top of these services, and the ability to surface vulnerabilities, resolve bugs, incident response through to GitHub issues. And what I thought was really interesting was that there's a couple of GitHub agents that I didn't realize existed. One of them was an SRE agent. Do you know that?
Yeah.
Yeah. Do you want to talk about that quickly? Just give my voice there.
A lot of our research is actually about
Okay.
I don't want to get into the jargon of that, but essentially what it is that there's data transmitters and this data is being fed into sort of feedback loop, and that feedback loop is what we use for the models that we release to the public. That's about it. It's just about publicizing functional data.
Okay. Well, I like this because this is an end-to-end life cycle that GitHub have basically published for deployment. There's about 3 or 4 agents in this stack that allow you to do everything from check code, manage all the way to like a software development life cycle to the end. Observability is built into the SRE agent. Yeah. It is, yeah. You pay GitHub a lot of money. Yeah. Yeah. All these vendors, eh? It does, yeah. Yeah. So there's like a 3 or 4 agent framework that cooperates to do all of this.
So I have a question.
Yeah.
Used for production, like Microsoft did something for production.
Yeah. Yeah, a lot of people are now. Yeah. Well, I mean, you probably know from a GitHub perspective what the numbers are, but
Yeah, I mean, a lot is actually
right.
but we are seeing some cases in the industry. I don't want to take a bit of time, but yeah, it's just it's mainly within actually tech and banking infrastructure finance.
It looks like your end-to-end full production system ready, like, so.
Yeah.
Is it not known this are being used?
No, I think it is. People are building this stuff. But I think enterprise builds this in parts. So, you know, yeah, but I think now, you know, things like surfacing vulnerabilities and resolving bugs, you know, these have become more mainstream now with AI. So I think it's the passive stuff that people trust, not the active stuff yet. But it's getting there. Oh, yeah, I've got like a whole load of stuff. There's about 4 agents that are in GitHub, from Copilot to the SRE agent to a couple of others, and you put them together and you get these things. Oh, yeah. In terms of using this framework to test, I don't know.
Call me if I'm wrong, but isn't this very similar to the software development lifecycle?
This is exactly the software development lifecycle. I think that's the whole point. You still can't take the developer out of this; they're at the center. But I think a lot of these are being outsourced. Where they were outsourced to things with business rules, they're now being outsourced to agentic workloads and, you know, and other applications. And like I say, these 2 things we're using ourselves, right? We surface vulnerabilities through our own applications. We do like bug resolution or improvements in software quality and things like that. So yeah, so this has just been commoditized. Of course. So this was new to me, but yes it has. But then you have to these use standard managed identities. So as long as you give it the permissions that you need, like you have to do with build boxes and things like that, then it can do those kinds of deployments. Yeah, specifically for Azure. I think it can be run through Azure DevOps, or it can be run standalone. Yeah, no worries.
If it wasn't Microsoft Azure, but a completely different environment or ecosystem, would this slide look any different, or would it be the
No.
same slide
No,
with just different names?
yeah, it's basically writing code at every single point and executing it. That's all. So whether or not you're building things and you're auto-generating Bicep, or you're doing the same for Terraform and doing the same thing in AWS, it's no different. No. This is an Azure workflow, but the question was that whether or not we'd have the same slide in AWS. I don't know what the AWS tools are to do this, or Google tools.
But that was
No, no,
the question, then
no.
what I asked.
No, it would look exactly the same. Yeah. Yeah, this is a standard CI/CD. So you would replace the services with a different agent, but every single point would be the same on here. Yeah. Yeah, that's right. Yeah, so the tools would be different and the services would, but the
different-
workflow,
Different names.
Yeah.
but The process,
the process would be the same. Exactly. Yeah. Yeah, process is the same.
that's what I wanted to understand, just
Yeah.
whether Azure had a very specific
It,
workflow in its own.
well, no, it has these agents now which are model for this. So Copilot, the SRE agent. I don't know what the AWS equivalents are, but they've probably got something similar. Okay, so before pizza, this is the something special. Who knows what that is?
What?
It's the quantum Majorana processor. Yeah, it's tiny, but this is like they call it a topological quantum processor, and they put these things called quantum dots in this, and basically, we won't go into the extravagancies of this because some of the science is crazy, but if you have a million what are called virtual qubits, then you've basically got a quantum computer that can solve large problems. I think that when we were there in March, they had one with 1,000. Was it 1,000? So there's a way to go, but you tend to find that the multiples happen very, very quickly because these are engineering problems at that stage. They're not science problems. Anyway, so I dumbed down what this was because Microsoft are not really known for this. So Google are very much known for this. There's some great Canadian companies that have got a strong voice on this, IBM as well. But this is quite a novel approach. So what Microsoft announced back in February was that they've got this new topological superconductor, and one of the things that you have to do with superconductors is you have to supercool them. So you need to take them down to as near absolute zero as possible, and then things get really super expensive. So everything's super, including the cost. So they have, Microsoft said that they've discovered a new state of matter, and in this you have tiny quasi-particles. So when we talk about states of matter, what we're actually talking about is, because there's lots of concepts in physics, like has anybody heard of a concept called Cooper pairs? Yeah, so Cooper pairs. So some people would call that a new state of matter. Technically, it's not. We know our 4 states of matter if we include plasma. We learn them at school. So it's a very, very broad definition of something. So what we know is that in certain states we have these things called they call them Majorana zero modes. This concept was discovered in the 1930s by an Italian physicist. So the Majorana was named after him. And when we say that these particles behave like their own antiparticles, what we mean is that when these particles group together, they're actually in a low enough energy state that they're not going to be disturbed as much. And what you tend to find, so you can see these MZMs, they're pinned at zero energy, and they're difficult to disturb. Really, really important concept with quantum computing. Well, it doesn't need to produce energy as such. So you can monitor intrinsic properties like spin, so that you can work out whether or not. So if we go to this one, this is actually the key here. So when you look to monitor something and when you expose it to the environment, and you're looking at absolutely anything. So you've got things like nuclear magnetic resonance. You've got photons. So a lot of people are using photons in the same way. The problem is that when you expose these to the environment and you monitor them, you you can change their quantum properties, and it introduces errors. So what you tend to have to happen is you have to have a system in place which will pick up these errors and error correct in exactly the same way as you do with the network, where you send packets around, you have to generate cyclic redundancy checks on the packet. The packet's disturbed, you test the CRC, it's wrong, you have to retransmit. So it's a similar property. It's a similar property in the quantum world, in that the more you look at something and you expose it to the environment, the more likely you are to, on the measurement, to disturb this and introduce noise. And when you introduce noise, you introduce errors. And one of the fundamental ways to detect an error is there's oh, my mind's gone blank. There's a quantum property called entanglement. So entanglement is this weird thing that Einstein used to call spooky action at a distance, primarily because he didn't believe it. He quoted this this really famous term about this called "God doesn't play dice." Do you guys? Yeah. So, but in the 1980s, in Lausanne, it was actually tested. So there was a physicist called Alan Aspect, and they tested the fact that they could take two quantum particles that were entangled, and entanglement can happen from where you have a reaction which occurs, and you might have an explosion of two photons. One goes in one direction, the other goes in the other direction. According to what we think we know about this, if you change the spin on one, then the spin on the other instantly changes. And so this entanglement is a property that we look at when we look at what we call quantum bits, which might be a photon, it might be this Majorana, these particles together. If we change the state of one, according to what we think we know about the quantum universe, if we throw something that's been entangled with this to the other side of the universe, then the state of that will change. It's really bizarre, and it tends to violate what we understand about causality. And everybody explains it through many worlds and all the rest of it. So we don't actually know how it functions, but we know from testing that it does function, and that we can detect these using distances and detectors like very, very far apart, and it happens faster than the speed of light. Okay.
So there must be a connection between the two.
Yeah.
Where information is being transferred.
And information is the key here. Everybody talks about this as part of information theory and not fundamental physics, because we don't quite understand the fundamental physics. But we also don't need to understand how to take this idea of qubits and build in error correction. And what the thing that makes this quite special is that because having a stable qubit is very, very difficult, and it makes it very error prone when you need to look at the answers, because qubits exist in this state of what's called superposition. So do you remember from high school your Schrodinger's cat?
Yeah.
Or Schrödinger? You know, until you open the box, the cat is both alive and dead. So until you say, I want an answer in the quantum computer, what you have is you have something which isn't coherent because it exists in all possible states. And the moment that you look at it and measure it, then it becomes a real thing.
Heisenberg.
Yeah, and Heisenberg's uncertainty principle, angular velocity velocity and mass. You can't measure one or the other property, and that's the problem in the quantum world. So you have to have very, very clever mechanisms like this. So the fact that the key here is that these Majoranas, if this is real, then they're less error prone than other quantum bits, qubits, and computers, which means that you need less of them to have the same ability in a quantum computer.
Yeah, are they chemistry? So when we talk about all the different states, are you talking about isotopes essentially?
So in this case, so I've got to be honest with you, I read through the first 2 pages of the, and it was like, oh fuck, I can't get to the end of this. But I think this is just talking about similar type states where you group particles together. But you have the reason. So in anything quantum, quantum scientists will talk about this thing called collapsing the wave, and collapsing the wave means that you have this superposition of states, and there comes a point where you have just one real thing in our universe. And we talk about coherence and decoherence, and the noise will make this decohere. And so what, if I go a little bit forward, there's some fault tolerance. They call these tetrons, but they have these gates around the qubits that we've been talking about, these quantum bits, to assess whether or not, and these quantum bits, in this case, they're called quantum dots, right? So they're tiny little groups of these particles which are super cooled, and they're put on the chip, and then you've got tiny nanowires in between them, which carry electrical current to work out whether or not this is decohered and it has an error, or it hasn't. Okay, and then that way you can do your super fast checks like you do with the network, with cyclic redundancy checks when packets fail, to make sure that you can detect the error. But the key here for all of this is that if this is real, you need a hell of a lot less qubits, and we talk about physical qubits and virtual qubits, and you need far more qubits to detect errors than you do qubits to do work. So it can be this huge multiple of trying to track an error and monitor it, compared to the things that are actually showing us. So when we talk about 1,000 qubits, right, that's huge. I mean, because that can represent like a 1,000-digit binary number, which we can, or based on the number of spin states that we have, so that when we do this, when we talk about factorizing keys and like literally brute forcing things, it represents all of these numbers at once, and then when we collapse this based on the problem, and you've got algorithms which can describe the problem, like factorizing large prime numbers, which will destroy SSL, TLS on the internet. It uses Shor's algorithm, so you can apply this to these quantum states. So I guess if this is correct, then the key is that Microsoft are saying that their system of quantum computing needs a lot less qubits, physical qubits, than other states. Okay, and people are looking like 1 million qubits and these kinds of huge ground to cover, but it's about shrinking the need for capability.
You said in concept that just a few minutes ago that large qubits it's actually like fixed.
For quantum error correction, yeah.
That's the same with Microsoft.
Yeah, so they're still going to need this, and I don't know what, I don't know enough to know what the key differences are. I don't think that anybody does yet, to be honest, until they can scale this up. But yeah,
I just think.
yeah, Yeah.
What's the difference? Are you familiar with the phone gates by any chance?
no.
Oh, it's just basically circuits with and or ones.
Okay, yeah.
Is there any difference really between that? Because the research paper was kind of glorified in many ways.
Yeah, so I think so there are quantum operators that they've got where you've got similar constructs of and NAND gates and things. But I think everybody talks about first off, everybody talks about all of the key algorithms like Shaw and Grover's because they're the things that we know that can do actual work. But one of the things that I've seen now that a lot of companies are gaining ground with this, you're basically getting software frameworks which a lot of the vendors are telling you to use in anticipation of this to start building your own algorithms and for SMEs around drug discovery and all of the sorts of things and workflows that they would do. I know Microsoft built one. God, it must be like at least 8 years old, maybe more, called Q Sharp. And you've literally got all of these operations in there, like we've been talking about, like superposition is a property and entanglement is an operation and things. So I tried this when it was released on my laptop, it crashed. It doesn't work well with what is now classical technology. But I think we are getting further on where that software is going to catch up with being able to run it on this kind of hardware. And what was interesting, and I don't know how much of this I can talk through. So what I might do is edit and bleep out a bit. In fact, no. Let me end this early, and then I'll tell you the bit that I'm not going to record. Okay. So. All right, let's end this early, and we'll keep the Q&A not online as well. So thank you guys. Going to end the recording now and going to tell you some secret stuff.
X-rays coming, they're just being really slow. Keep talking, I'm chasing them.